Okay, we're going to do properties of logs. Easy as falling off a log. Pause the video and take notes here. I will just go through it with you. So it says let b, m, and n be positive real numbers with b not equal to 0. I'm sorry, equal to 1. So you've got the product property, the quotient property, and the power property. Because remember, logarithms are exponents. Just remember that. A logarithm is an exponent. So if you can connect those two, it will be much easier. So just a quick review of the product property of exponents. Remember, if we've got, say, x squared times x to the third, the product property says that we add those exponents, x to the 2 plus 3, which is x to the 5th. Okay, so you remember logarithms are also exponents. So the product property says that if you've got the logarithm of two numbers being multiplied together, which the answer to multiplication is product. So you get two numbers being multiplied together, then you can add them. So you take that same base, log base b of m plus log base b of n. That's just how it works. So you remember the product property of exponents is the same as the product property of logarithms, because a logarithm is an exponent. Quotient property, quick review. Quotient property, remember, if you have x to the 4th over x to the 3rd, you're just going to go x to the 4 minus 3. You subtract. So quotient property of exponents, remember, we just subtract. Same thing here. Quotient property of logarithms, if you've got a quotient, which is the answer to division, m divided by n, you're just going to subtract logarithm of m minus logarithm of n. Same as the quotient property of exponents. Now, look at the power property. The power property, let's go back to the power property of exponents. If you have, say, x squared to the 3rd power, then what you remember what to do with those exponents? You're just going to multiply them. X to the 2 times 3, which is x to the 6th. Okay, so now think about this with logarithms. If you've got the log of a number raised to a power, we're going to take that power and we're going to move it over here. And you do have to do it in order. So all we're doing is we're going to take that power and multiply it by the original exponent. So that we're taking that exponent that's n and we're multiplying it by the exponent that's log base b of m. So you put it out front. So n times log base b of m. So the power property says you multiply, just like with exponents. So if you can connect it to something, every time you're learning something new, if you can connect it to something that you already know, it's very helpful. And this is great because it, like I said, logarithms are exponents and they just connect to your properties of exponents, your laws of exponents. Okay, so we're going to go ahead and see what we can do to use those properties. Okay, so pause it and give it a shot after you think you know what's going on here. So we're going to start with number 1, and log of x minus log of 9. Well, that would be the quotient property. So if we're going to condense that, it's just going to be log of x divided by 9. If we're going to condense this other one, they're being added. So that means we just multiply those answers together. So log base 2 of x, y, x, y. Okay, now, if you look here, we've got a number times an exponent. So that means that that number used to be an exponent. So that's log of b squared. Okay, remember for number 4, natural log, this ln is logarithm natural. So natural log. On your calculator, it might look like in, but it's ln, natural log. Natural log of 4 plus 2 times the natural log of x. So remember, PEMDAS, remember, you know, we got to look at exponents before we start multiplying. So we're going to look at that. If we're simplifying, we want to look at exponents first. So we're going to take that 2 and move it up there. So this is going to be the natural log of x squared. Okay, and then we still have it being added to natural log of 4. Natural log is the inverse of e. That's why on your calculator, those are first and second functions of each other. Natural log might be like your first function. E to the x would be the second function of that natural log. Log, remember that if you don't see a base, log, no base shown, that's log of 10, log base 10. And that one's on your calculator too. And it is, the second function of log is 10 to the x because those are inverses. Log, and we'll talk about that a little bit later when we are simplifying things. So let's keep going with this number 4. So now we're adding. So adding, remember, is the result of the product rule. So natural log of 4, remember, we're going to multiply 4x squared. And that's how that works. If you want, you can just watch this and then, you know, write them down, watch how I do it, then go back and try to do it again. Rewind it to where you haven't seen me do it and you try it. That might be some good practice to learn this. So, okay, we're going to keep going. We're going to condense some more here. And it looks like we're getting into a little bit, you know, more serious stuff. So log base 3 of x plus 4 times log base 3 of y. First, you have to make sure they're the same base, which all of these are, I believe. Yeah, they are. Okay, but anyway, first, you see that being multiplied. So just like with PEMDAS, you know, E comes before multiplication, division, addition, subtraction. So exponents first. So first, we got to do that log base 3 of y, and we put that 4 up there as an exponent to the 4th. And then it's added to log base 3 of x. Now, addition would be the product rule. If I had thought a little bit more about this, I would have gone the other direction first. But anyway, so log base 3 of x, y to the 4th is your answer for that one. It's all kind of squished in there. Let me see if I can fix it. There we go. A little bit. I don't know if that helped. We'll see. Okay, the next one is first, again, you're always looking for things being multiplied. So the 2's out front. Uh-oh, I moved it to where we can't see that whole thing. Sorry about that. Okay, so and I need to erase some stuff. Okay, so we've got a 2 out front. That means we've got an exponent. So we got to take care of that exponent first. If you want, after you got it written down, rather than having to copy it, if you want, you could do this. You could go, okay, well, let's move this guy over here like that. Now I'm subtracting. Remember, subtracting is what you do with the quotient rule. So that means we've got a quotient. We've got log base 4, and then the first one, a squared, goes on top, and then 9 goes on bottom. Okay. Now, the next one, log base, or 3. So here again, here we've got 2 exponents. So we might, yeah, we get different bases, so we're okay. So again, if we want, we can just save a little time by throwing that 3 up there. And save a little time by throwing that 6 up there. Like that. And now we've just got log base 4. We're condensing, when it says condense it, we're condensing it into one logarithm. So log base 4, we've got x to the 3rd on top, y to the 6th on bottom. Okay. And now natural log. The reason you don't see a base there, remember that natural log is the same as, log base e. So that's a shortcut way to write natural log, or write log base e. It's natural log, ln. Okay, we're going to take this 6 and put it up here. I'm going to take this 5 and put it up here. And now we have natural log of x to the 6th over y to the 5th. Pause the, please make sure you're pausing and trying this on your own before you watch me do it. Okay. Now we're going to expand. So here we go. We got log of 18 times x. Remember log base what? It's log base 10. So we're expanding it, which means we're going to have more than one log. So log 18, they're being multiplied 18 times x, so plus log x. Okay, this next one is dividing. So dividing means we're going to subtract. Log base 2 of 3 minus log base 2, and make sure you get your bases in there, of x. Okay, then we've got an exponent. That exponent's got to come down front. So this becomes 2 log base 4 of x. Now we got a couple of things. Now, just like we followed PEMDAS before when we were condensing. Condensing means we're simplifying. Expanding is kind of like solving. So we're going to do upside down, SADMET. We're going to do the exponents last. So that means we're going to go log of x to the 7th minus log y, but we don't want an exponent in there. So that 7 has to come down front. 7 log x minus log y. Okay, so if you're going to learn this, you probably need to rewind, practice, whatever it is you need to do. All right, so here we go, more expansions. And again, like I said, we got to do SADMET. So remember, PEMDAS, parentheses, exponents, multiplication, division, left to right, addition, subtraction, left to right. If you're solving, that's a piece of cake. It's so easy. And this one is a piece of cake upside down. Still easy. SADMET. Okay, so we are multiplying. So we're going to do the addition first. We're going to do that bottom part first, upside down. So log 9 plus log x to the 5th. But now we have to do exponents. So we're actually going to take that 5 and we're going to put it in front. So you can fix it if you want instead of having to rewrite it. I'm going to erase my little thing over here so we have room. Okay, so now we got it, 2 of them. So we're going to go log base 3 of a squared. And if you can do it, without steps, then go for that too. You get so good, you can do it without steps. I'll go ahead and do the second step here. We have exponents, so we've got to bring those exponents down. Use the power rule and multiply them by our logarithms, which are also exponents. So 2 log base 3 of a plus 5 log base 3 of b. Okay. Over and over. And now, like I said, now pause it and try these next ones. I'm going to do this. Well, I'm not going to shortcut it. I'll do it the long way. But if you can shortcut it, shortcut it. Log base 4 of x squared is the quotient rule. So we're subtracting log base 4 of y. And now I'm going to be lazy and make that 2 come out front. That's all you got to do. Okay, so this is the quotient rule again, log, not base. So if there's no base, it's 10, remember. So just log, that was the easy one, fall off that log. Log of b to the 3rd, and now minus log c to the 4th. And again, I'm going to be a little lazy and bring that 3 out down front and bring that 4 down front. Okay. Now we get into the base change. This is the base change. the base change formula. So write that down, pause it, and write this base change formula. So log base C, you got to pay attention to the base because you're doing a base change. Log base C of A. Okay, so we're going to just use, this one says log base B. Usually you use just plain old log, and it's showing you here. And so I mean, I guess you, okay, I already told you to copy that one, but this is really what you're doing. So, I mean, because you're always either going to use, you're going to use the ones you can put in your calculator. Okay. So, when you change it, so you're going to change it like the B up there, kind of silly. Log base B, it's okay. Well, on the one on the left, we're using 10 because it's just log. The one on the right, we're using E because it's natural log. So, but the main thing to know, the big thing to know here is where to put which number. So whatever the base is to begin with, you're going to put on the bottom. So the idea here is to get it so you can put it in your calculator. And so if you have log base something of something, anyway, you'll understand it more when we do the numbers, but make sure you do the C, log of C, whatever the base is, goes on the bottom. And then the answer, log of A, that goes on top. And then you, like I said, you can use either one because either natural log or plain log, which is base 10. So if we want to find the value of log base 8 of 32, we are going to do the base change formula. So we're going to go 32, log of 32 on top, and log 8 on the bottom, and you put that in your calculator and it gives you the answer. I have some pages with answers to show you here in just a second. I don't have my calculator in my hand, so I'm going to let you do that part. The big thing is knowing how to change it. So this one's not done. You're going to have to, you know, round it. Anyway, so here, log of 18 over log 4. Okay. Let's see. Go to the next page and probably a little bit of practice here. Yep. So to do these, now you pause this and you do them, and maybe do one and then unpause to see what I did, and do another one, unpause to see what I did. So this one's log 16 over log 3. You can always use natural log. You could go natural log of 23 over natural log of 4. You're going to get the same answer in your calculator. That's the beauty of the base change. Log 82 over log 7. Like I said, I've got the answers here in a little bit. Now, this one is weird. So log of 7 over 11 over log 2. That's all you got to do. Okay, I'm going to go ahead and go to the page that has the answers. Not that one. That one. No, not that one. That one. That one. Oh, did I not? Maybe I didn't do the one with the answers. I'll give you the answers. Let's see. I'll go back and give you the answers in just a little bit. I'll put them at the end. Let me pause real quick. Okay. So log 32 divided by log 8. Now, when you put that in your calculator, make sure you close parentheses after 32. That is approximately 1.6 repeating. No, not, it's actually not even approximately. It is 1.6 repeating. Because repeating is exact. So if it were, yeah, if it were Not repeating. If it were not terminating or repeating, we would say approximate. Oh, I still didn't erase that equals. So it is exact. It's not approximate equals. It is equal to 1 2/3 or 5/3. We can look at all that later too, though. So that's kind of cool. But okay, then you can put that in as natural log or log. So if we put this in, it doesn't matter what that says. Log base 4, it's going to say LOG. But if you put in the two that you can put in your calculator, natural log and log. So you could put in natural log of 18 over natural log of 4. That looks like a 1. Natural log of 18 over natural log of 4. And you don't forget to do your parentheses. You will get, now this one is 2.0, wait, it's just too long to put in. So we're going to say approximate. And I'll put it up here because I don't have room. But 2 point, and usually you do 4 decimal places, 0, 8, 4, 9. We're going to go 5 because it's 9, 6. So rounds to that. So that's what you should have gotten in your calculator. 2.084962501. Anyway, maybe it is irrational. I don't know. Okay, so for these, I'm going to give you the answers. I already showed you how to set them up. So I'm just going to make sure we've got the answers. I'll pause and write all the answers on here. So hang on a second. Okay, so I put all of those into my calculator, and that's what I got. And sometimes it's kind of fun to play around with this. Just to, I think it's fun because I love math. I'm kind of a nerd like that. But it's fun to see, like you put in natural log of 23 divided by natural log of 4, and you get that answer. And then you put log 23 divided by log 4, and you still get that answer. So that's really cool. Anyway, that is how you do this. Maybe I'll do another recording with the actual lesson. So have a wonderful day.